All right, we're up. Okay, so we're going over section 2, right? Group 2 or part 2?
Part 2, yeah.
All right. Is it just me, or are there only 2 questions on here?
Only 2 questions.
Yeah, only 2 questions, and they were kind of
easy tonight. I shouldn't say that out loud. Sorry. I just need to the rest of the term. All right. Well, I'll start then.
Well, I think on this we just need to see if anybody has any questions on it, and then we have to do the quiz, right?
Oh, that's right. That's right. Was everybody good?
Yeah. I'm afraid it's going to get more complicated, but these ones were easy.
Okay.
I was good and I understood it. Me and my husband went around and around last night, and I was like, it's fine, I can do it, I get it. But to me, the example, and I posted a question in the discussion board on iLearn, but to me, in the dice example, numbers 1 through 6, to me are categorical numbers, not quantitative numbers. My husband says no, they're not. They're just quantitative, don't worry about it. But like I posted a question with some pictures. So like my kids in one of their kid games have a dice that has a color on each side instead of a number. So if I want to roll that colored die 6,000 times, can I not figure out the mean of rolling a red? Because a red's not the same as 2. Do you assign a number to those?
I think in this case, what you're talking about, because dice, if I'm thinking about it correctly, if you're playing a board game, dice can be quantitative because you would add them together to get a number, right?
Okay.
But in this case, if you're using them to just roll the dice to see how many times you get each number, that would be quantitative. Because you're not adding up to a sum, you're seeing how many numbers you get. How many times you get that number. Am I thinking about that correctly?
So
your husband's on a mission.
I look at it as
he's lingering. I know he's lingering because he wants some input.
No, I mean, you said quantitative twice, but you meant categorical the second time.
Yes, I did. Sorry.
Yeah.
Because you can't calculate the mean of red. You can calculate the probability of red. But that's a different thing. The probability, you don't need quantitative for probability. Probability can be based on categorical because it's just how often this category happens compared to those other categories. If you want
to assign the categories a number?
To do it in SPSS? Yeah, you can dummy variables. If you're going to use a statistical program to calculate the probability, then you set up dummy variables that just turn the categories into numbers, but they don't mean anything. Like a super common dummy variable is female and male, and you get female 0 and male 1. And then you can use the program to calculate, to sort and categorize and do all kinds of things on the numbers. But they're not real numbers. They're just there to allow the system to work with them.
Okay, so like I know we didn't have to do any of it actually in our homework, but in the textbook and going through all of the textbook stuff, when they found the standard deviation of discrete random variables, they used these numbers from the die 1, 2, 3, 4, 5, 6 and multiplied it by different things. They multiplied it by so they rolled a 2 968 times. So they multiplied 2 by 968. So if I had a colored die and I rolled a red 968 times, could I not calculate that because it's red instead of a 2? Or am I just worrying about things that don't matter? That's what my husband tells me. Don't worry about this. It doesn't matter.
Well, because the discrete numbers were ones that you could calculate, like a definitive number of times you could do it, I guess. I don't know. That didn't really make sense, but like you can't, if you mix you can't get like in between like
That
a
just-
red and a blue, you know? So like finding the mean of the red and the blue. I have this shade of purple, you know what I mean? So
Okay,
you
yeah.
You can't get like in between colors for your mean. You wouldn't be able to calculate it because they're colors. So it wouldn't be a quantitative.
We get into
Okay.
discrete random variables too in-depthly because she said they're way too complicated for this particular class. So she just kind of glossed over it a little.
That's just my take on it. Because I
No, that
don't
makes
necessarily
sense.
think that the numbers necessarily mean anything on the dice, but I think
Yeah.
because
and-
they are numbers, you can calculate stuff where they mean something.
Yeah, you're exactly right. Right, it's like the mean doesn't mean anything either. It just happens to be 3.5. You know, if every number was exactly equally likely in the entire set, you'd get 3. Ends up being 3.5. But that just happens to be a way of saying that the sample has slightly more large numbers than small numbers, right? Is it 3.5? Oh no, it's 3. Yeah, 3.5 is what it. Yeah, 3.5 is what it actually is. Yeah, I don't think that the I don't think that the fact that you are using numbers in this case matters, except that there happen to be numbers and it could have been something else instead, like colors. But you can't, like you were saying, you can't get a value that's halfway between two colors.
Yeah. Okay. That's good. We can move on, but
Thanks for making it complicated.
I think everything complicated. I was telling my mother-in-law today, I remember one time in a high school calculus class, I think the teacher probably could have like beat me by the end of the class. And I could do the problem, and I could get the right answer, but I was just like, but why? But why you do it that way?
That is me in a math
And he
class.
was like,
My brother,
you. But
my
why?
brother used to tutor me in math because he's an electrical engineer. So numbers are his thing. But oh man, he'd get so frustrated with me. He'd be like, you know the answer. Quit thinking about other things. Just do it the way I said. It's like, who cares
My
about why?
husband's
Just do it
an
this way.
engineer too. And so last night he was like, it just doesn't work out that way. It just is what it is. Do you get how to do it? I'm like, I get how to do it. I just want to know.
Yeah, I'm the same way. I have to know why for everything. It's like if I have, if I get this particular, if I see this particular equation, I'm supposed to know that I need to do this with it. But why? Why is that the case? And
Yeah.
Doesn't need to
It's
be that
fine.
hard. But it is.
But no, the assignment was easy. I just overcomplicated and so.
I can relate perfectly. I can relate. All right, should we move on to the what you call it?
The quiz.
The quiz.
Yep.
All righty. All right, so let me know.
Right?
Holler when you're ready.
Okay.
Everybody else ready?
Yep.
I do believe so.
Yep.
Okay. La. Okay, give all your probability answers as decimals. Okay, not as percents. All right. Human blood can be classified into one of 4 basic types, O, A, B, and AB. The proportion of these in the population of the United States with each of these blood types is summarized in the following table. Okay. So the blood type and proportions given in the table above define a probability distribution.
True.
I say true.
Okay.
0.85. 7, 8, and yeah. Okay. Just had to
What
be
does it
sure.
add up to 100?
Yes.
Okay.
Just to be, just to cover my bases.
Okay, then I'd say yes too.
Do you want me to do the next one?
Shoot. Go for it.
Okay. What is the probability that a randomly selected person in the United States has type O blood? So I look up at the chart above and it's 0.45, right?
That's what I would
I
say.
agree. Do you want to read the next one, Sarah?
Sure. What is the probability that a randomly selected person will not have type O blood? And then subtract 0.45. So I'd say 0.55.
Agreed.
What I got.
Okay.
Okay, I'll take the next one. Use the following information to answer the next two questions. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrated the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round answers to 3 decimal places. So up in the top, it says we have 7 bowls lined up. And only 1 contains the bladder cancer specimen. So we'd have 1 out of 7, which is 0.143.
That's what I got.
Agreed.
Okay. Yep.
I think we're back to you, Mary.
All right. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There's little evidence that dogs can detect bladder cancer. All right. So if they do it 22 out of 54 tries, that's less than half. So I would say little evidence.
Is it half or is it 5% of the time that you do that though? So is it like 0.5 or is it 0.05? Because I thought it was 0.05.
I think it's 0.5.
Where's my calculator? Let's see. Okay, so how are we? Because if they do it 22 out of 54 times, that's only
Point
that's only 40%.
40%.
So are we saying little evidence?
I think it's strong evidence.
That's what I thought too, because I thought it was 0.05% of the time was the little evidence.
Yeah, I'm going to say strong too.
Okay.
I mean, only 40% of the time were they correct, but they were choosing between 7 samples. And in the in the question, it says, it is very unlikely that the dogs would do this well by random chance.
Oh, that is true. Okay.
So even
Right.
if we're not looking at the numbers or doing math, which I'm really not, but just that statement in the question makes me think it would be strong evidence.
Okay.
Go with it.
All right. Use the following information to answer the next 3 questions. M&Ms are small chocolate candies. The M&M's website previously indicated that in the United States, the distribution of colors in a bag of plain M&Ms is given in the following table. So question, if you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? And I say 0.13.
I'd agree.
Yeah.
Yep.
Okay. What is the probability that a randomly selected candy is green? So I have to do some addition here. I got 0.16.
Agreed.
Yep.
Okay.
What is the probability that a randomly selected candy is not green? Round to 2 decimal places. So since green was 0.16, I'm just going to take 1, subtract 0.16, and it's 0.84.
Yep.
Agreed.
All right. All right. The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from CapEx.com. The following summary statistics were calculated. Okay. Half of the observations are less than or equal to what number? Uh, 24.3. No, median, 24.
Yes.
Agreed.
Yep.
All right. Based on the information on the table above, the top 25% of students scored above what number? 22.
So I think that it would be 27 because it says the top 25%. So you're looking at that last quartile, not the first. Is that correct?
That's what I would say.
Oh, yep. I think you're right. Yep.
Yeah.
Is it my turn?
Yep.
Which of the following statements is not one of the 3 rules of probability? If the probability is high, then the probability. If the probability is low, then the probability is negative. Is what I would pick.
Agreed.
Agreed.
Sweet.
All right. This was record time.
I know,
Yay.
even with me being slow finding the link and getting on.
That's all right. It was, user error for me.
No, it was fine. I'm sure, like, in a few minutes, my email will come through or something. Like, awesome.
Sweet.
All right. So Sarah's up next.
Sounds good.
Yes. Okay.
8 o'clock on
Thursday.
Thursday.
The answer?
Thursday, the same time, whatever time
Sounds
zone you're in.
good.
What time zone are you in, Sarah?
I'm in Mountain Standard.
I am too. So 8 o'clock for us.
Yep.
All right. Thanks,
All
guys.
See you Thursday.
See you later.
See you later.